In this module, we will go through t-tests and analysis of variance, also known as ANOVA. Generally, it's better to use statistical software to analyze your data. That said, since you're likely to always have access to Excel, it's good for you to know how to use it. A t-test is used to test if the average value of several observations between two groups is statistically different. So the data we're looking at today is soil moisture between two experimental fields. Our interest is to see if the percent moisture is significantly different between sites. So we'll be using a two-sample t-test, assuming equal variance and a two-tailed distribution. I'll explain these terms later. So the first thing is to see if your data analysis tool has already been downloaded. So you need to go to the Data tab, and the Data Analysis tab should be to the right, and looks like we don't have it. So if you don't have it, go up to File, then go down to Options, then Add-ins, and then select Analysis Toolpack, hit Go. And then check the first box. Hit OK. Now you can see that the data analysis tool has appeared to the right. Now let's run a t-test in Excel. So go up to Data, Data Analysis, and here we are going to select a t-test two-sample assuming equal variance. So you'd have to go down. Then check OK. So for the variable 1 range, select the data in field 1. And for variable 2 range, select the data from field 2. Make sure that you check labels because we copied the labels for each variable along with the data. Create a new worksheet and hit OK. So here's your data. The first thing I'd like you to do is to rename this sheet. So go down to the sheet 1 at the bottom and call it maybe t-test results. Expand the first column so you can see the terms used to explain the results. Remember, our hypothesis is that the percent moisture is different between sites. So the mean moisture is on the first row. Field 1 has 11.41. Field 2 has 10.65. So again, we want to know if this difference in means is statistically different. Our sample sizes are listed here, 72 and 80 respectively. So you have two options to pick from, a one-tailed test and a two-tailed test. A one-tailed test is used when the distribution is either greater or less than a certain value. In a two-tailed test, you're looking to see if the sample is greater or less than a certain range of values. So in this case, we have a range of moistures in the two samples, so we are looking at the p-value of the two-tailed test. Remember, we set the p-value at 0.05. So if your p-value is 0.05, it means that there is a 5% chance that your results can be random. In this case, the p-value of the two-tailed test is 0.075, so there is a 7.5% chance that the results are random. While this is a small chance, we would reject the hypothesis that the percent moisture is different between sites. Okay, so now we'll move on to analysis of variance, or ANOVA. ANOVA is a statistical model used to analyze the difference among groups of means. So essentially a t-test is the same thing as an ANOVA, except it's a special case where you have just two groups. In the example that we're looking at today, We're testing to see if the growth rates vary among 5 types of rootstock, which is used in an apple orchard grafting experiment. So it's going to be very similar to the t-test. So we'll go up to the data analysis tab, right, as we did before. So data analysis, and select ANOVA single factor. Click OK. Identify the range. In this case, the data has been already arranged in columns. Remember to check labels and create a new field. Click OK. Here you have the results. Make sure that you rename the sheet as one-way ANOVA results or something like that. Now let's look at the results. We chose single factor because we're comparing a single measure, which is the average growth. Groups in column A are the 5 types of rootstock. You can see the average growth in column D. Moving down, you can see that we're interested in differences between groups. So look at the p-value. It's 0.28. What that means is there is a 28% chance that these differences are a result of chance alone. So we reject the hypothesis that there are differences in growth rates between rootstocks. Another value to look at in these results is the F ratio. The closer the value is to 1, the more likely we are to reject the hypothesis. So a large F ratio means that the variance among means is more than you would expect by chance alone.